Hi, welcome to the channel. I'm Vladimir and I make videos about programming. In today's video, we're going to discuss variables in JavaScript. In the previous video, we discussed types and the type system behind the JavaScript language. And today we're going to focus on understanding how to work with variables and scopes. Let's get started. Variables, declaration and scopes. Here's what we'll discuss now. We'll talk about let versus const, variable declaration, and also about the scopes of a variable and some tricky things that can happen in JavaScript and that we should avoid. Switching to the IDE, I have a clean workspace here. Let's create a new function or new file, and we'll say let const.js. As we all know by now, if we declare a variable by using let, we can leave it uninitialized. If we console.log this on the screen, it's going to print undefined, and then we can do the initialization. We can assign it to whatever other value we want. We can say it's 5. We can also say it's a new object, which says like name again. It's my name. I can do whatever I want with x. I can also say x is equal to 5 again, and we'll say x is equal to x plus 10, and it's no problem, right? So we can do whatever we want with let. I mean, whatever we want, quote unquote. I mean, we can reassign the variable to something else. Now, this, of course, I could even do a string, is no problem. This is fine in JavaScript. Once we start working with TypeScript, we will have more restrictions, which are actually good, right? Because imagine that I would expect this string here, not the string, this variable to be a string. So I'll say string here. And that's fine for me, console log x. But then here I would like to do something like this, console.log, or even better, let's declare a new variable here, const or let, whatever, let y is equal to x.concat, and we'll say second part, right? So we want to add a couple of, or we want to add another string at the end of this x string here. So let's say that at the bottom here, I will attribute x to 0, or I will assign 0 to x, and then I would like to run this command here. And if I save this and I try to run this in the terminal with node let const, I'm going to have, boom, an error, right? Because concat is not a function for a number, even though it is a function for a string. If I simply erase that assignment, that's fine. The code is going to execute. And in the end, if I were to console.log y, then there are no problems here, right? String second part. So the flexibility also comes with many drawbacks, and you may start having very annoying bugs if you are not careful about the type that you are storing in a variable, right? This is a discussion maybe that will become more relevant later on, but I can already tell you that TypeScript also addresses this problem. It tells you, okay, x should be a string. It should always be a string. So if you try to assign something that is not a string, you will have a compilation error, so you will not be able to compile your code. But once the code compiles, you will know that you are always working with a string for variable x. Let's move on to the discussion of using const. So we are going to start again const here. That's going to be a number, 10. And as we know, we cannot reassign this value, right? Let's try to reassign this. X is equal to 15. And we'll say try catch. If you catch an error here, just console.log. And here I'm going to use the interpolation. I want to print the name of the error, and this is present in e.constructor.name. I can then access the name of this class here, and I want to print the message, right? So the name and the message is available at e.message. Why am I doing it like this? Well, it's because then we will print the error on the screen, but we'll still be able to continue the execution of the code. If I were to write here console.log x, then this is also going to output 10 on the screen. It's going to output something, I think it's a type error, and it's going to say that the assignment is not allowed, and then it's going to output 10 on the screen. Let's see here. I'll clear the whole thing, and I'll run node let const. Exactly. Type error, assignment to constant variable, and then it continues the execution. Now, of course, if I were to create a new variable here, const y, right? Const y is equal to 15. That's okay. It's no problem. So we'll just output 10 on the screen. And as you may have noticed, if I come back here, when I started writing, I actually wrote const x, and this didn't give me any error. Let's save this and let's run again, and we have no output error. We have no type error here. Why is it so? Well, that's because we are in a different scope. We are in an inner scope when compared to this whole file here. We'll discuss scopes in a couple of minutes, but I just want to tell you that it's okay. This is called a shadow variable. I mean, it's okay, meaning you can technically do it, but in reality, you should never, ever do it. You should never, ever shadow variable names because it's extremely confusing. But in any case, that's just the reason why you are not having the error if you declare the const x here inside of the try block. That's of course the same if we work with strings. So let's say we have a string a here and we would like to reassign the value to a, b, c, d. We cannot do that. So if I were to run this code, I'll have the same problems. But I can of course use a method from x, and I can say const new str. This is going to be x.concat, and then I will add whatever content I want here at the end of x. That's okay. I can then console the new string. Oops, not const, but console.log new str, like so, and this is going to output a, b, c, d, and in the end it's going to output a. Right, so this is what working with const means for primitives, and let's start discussing a little bit how it works for non-primitive values, meaning object values. Now, object values, as we already discussed, they are mutable. So once I declare them, I can definitely change their shape. I can add a name here, and I can delete that name if I want. I can add a method x.getName, for example. This is going to be equal to a function, and that function is going to return this.name. No surprises here. We already went through this whole thing. If I were to console.log x.getName, this is going to output John on the screen, right? Nothing new. The problem here, and actually not the problem, but I'm able to do that because I am not changing the reference. The reference is still the same. X is still holding the reference to wherever the contents of this object are stored. What I'm changing here are the actual content. So I can do that, it's no problem. The problem would happen if I were to try to reassign X to a new object. Then I'm going to have this red squiggly line here saying that's an error. You cannot do that. You cannot reassign a variable to a new variable, to a new reference, if you have declared it with const. If I declare it with let, that's okay, I can do it, but if I declare it with const, I cannot. To close the discussion on variable declaration, let's implement a slightly more complex example. We'll say we have here person 1. This person 1 is going to have a full name, and that's, first name, and that's going to be Lauro, right? And that's okay. Now let's say we have another const age. This is going to be 27. And then we will try to change the first name of Lauro to something else. We'll try person1.firstname is equal to John. And that's okay, right? This is fine. And we'll have to add a catch block here because, well, we are trying to do something. I mean, we could do that outside of the try. It's outside of the try block is no problem. But I just want to, start working around with try and catch. You will use this very often in later implementations. Of course, in real world projects, we'll always try to, or you will try as much as possible to wrap this whole thing around try and catch statements so that you can handle errors gracefully and you don't break your whole program. So here we'll say console.log, just simple error, right? We know this is not going to output anything. Now we are going to create an array. So my people, right? My people. And this is an empty array. And here I can actually add a couple of people. Can I do it like this? My people is equal to person 1. No, right? I cannot, because this is declaring a new array. It's creating a new instance of an array and it's trying to assign a new reference to my people. So JavaScript doesn't like that because I initialized it, not initialized, but I declared it with const. So the way to add new elements to an array in JavaScript is by using the push method. Let's push person1 into my people, right? And let's also push another person, my people.push. And here I want to create again Jane, right? First name Jane. And I'm pushing also another object. So now I have two objects within the my people variable. Now let's say that I come here to person1 and I change the first name of person1. First name is going to be John, right? It's going to be John. And once I console.log my people, what do you think this is going to output on the screen? Now, of course, if you're paying attention, if you remember what I discussed earlier, this is going to output John and Jane, right? So first name John, first name Jane. And why is it so? It is because, again, the array here, when I push this person1 variable, I'm actually pushing the reference to person1. So if I change person1, then this is going to affect the contents, not the contents of the array, but when I print the array, it's going to look for wherever the content of this person1 reference is stored, and it's going to print whatever is there. And because we changed it to John, it's going to print the new value. Let's try to run this here, and you see we have first name John, first name Jane, right? So this is something that is quite tricky if you are working with arrays and storing objects within arrays. You have to be careful how you handle the objects, because there may be effects in other parts of the code. Okay, we can mark the first half here completed. Let's discuss scopes. So for scopes, let's create a new file, scopes.js, like so. And if we declare any variable here, of course, this is going to be available throughout this whole file. But if I were to try to console.log it here, the IDE, I don't think it's going to complain, because it's going to recognize that it is in another file. But of course, for JavaScript, this doesn't work. It doesn't work like this. So if I were to run here node let const, I'm going to get an error, right? If I were to use this my variable here, my var, outside of this file, I would have to export this. I would have to export with the export keyword, right? We'll discuss this when it comes to modules, and when we talk about modules more towards the end of this course, we'll see how to work with this exporting variables, importing variables, and so on and so forth. Here, let's stick to one file, and let's discuss the scope within this file. Now, this my variable here, let's change this to let, because I want to do a few operations with it. And let's start with declaring a function, right? Let's say here function, the name of the function would be bad function. Bad function, because bad function is going to change the value of my var to my var times 2, right? Now, of course, here, if I then console.log bad function, console.log my var, this should output 20 as long as I call bad function. If I don't call bad function, then the whole thing is not executed. So let's compare the output of the first console.log with the last console.log. Save this, back here at the terminal, node scopes.js, and you'll see that it successfully mutates the value of my var. Now, why do I say bad function here? Well, this is an extremely, and I repeat, extremely bad practice, because we are changing a variable that is outside, that is in the outer scope of this function, which means that we need to keep information about the scope of the variable, and also which code blocks are changing the value of that variable, so that we can have an idea of its final value. This is horrible, right? So we should never do that. We should always work with inputs, with parameters to the functions, and with return values. So a better way of doing it, it would be to receive this as an input, x here, and to simply return x times, or x times 2, right? I think this was the expression. Okay, so let's copy this to a good function, right? Instead of having it, changing it here, let's create a new function. This is going to be the good function. Good function is going to receive x, and it's going to return just x times 2. Now, instead of running the bad function, I'm going to create a new variable, which is going to be y, and I'm going to have, or going to call good function, passing the myvar. Now, if I console.log myvar, it's still going to be 10, but y now is going to be 20, right? So I'll execute and we have 10, 10, and 20. And this is definitely the way to go. You pass all the inputs that you need via the function parameters, and then you return all the values that you want out of that function via the return statement. You really should avoid changing variables that are in the outer scope of functions. To illustrate a little bit better scopes, let's now start working again with, or something like this, let my var is equal to 10, and I'm going to declare a code block. So code block is any block of code that is between curly brackets, right? This is, you will see this in functions, in objects, and so on. But if you see them by themselves without any assignments nor anything, it means that's a code block. And code blocks define basically scopes in JavaScript. So within this code block, I can access anything that is within the code block and outside the code block, right? So if I were to declare here const my var2 is equal to my var times 2, this is okay. I can access my var from the outer scope. However, if I were to console.log my var2 here, then I'm going to have a problem because the scope of my var2 is only the inside, or it's only valid within this code block. As soon as I leave this code block, then my var2 cannot be accessed anymore. Let's save this and let's run here to get our error saying that my var2 is not defined, right? So this is the basics of how scopes work. Of course, within here, I could also say my var3 is equal to my var plus my var2. This is also variable, also valid, no problem. And of course, if I were to try to access my var3 here, this is also going to fail. Now, the last thing I want to discuss is shadowing variables, right? So shadowing variables simply means declaring a variable with the same name as another variable in the outer scope. So here, let's create a new variable myvar, and we can work with, let's say this is going to be 20 here, and we'll say console.log 20, sorry, not 20, but my var. We'll see that within the inner scope, this is going to be 20, but as soon as I leave the inner scope and I console.log my var in the outer scope, this is going to be 10 again. Let's run the code here, scopes.js, and we have 20 and 10. Now, of course, this is extremely confusing, right? But extremely confusing, because if I were to declare another one here with a 30, then, and I console.log my var here, then I need to be also aware of the scope of this variable, or of the extent of this code block. And this is horrible. It's just hard to see where this value is coming from. Now here is very clear, but what if your file has 100, 200 lines and you have all these little blocks here and a lot of shadowing within the functions? It's also fine to do shadowing within functions. You can do that. So function add shadow, right? Or shadow add, for example. Let's do it like this, shadow add. And here we can say const my var is equal to 10, and we'll just, let's say here we're going to receive some parameter, and we'll just console.log a plus my var, right? And this is fine, but you know, imagine like if you're redeclaring it here, you then really lose a lot of meaning. You need to keep a lot of things in your mind. Now this is, again, bad to do. I would discourage you to do it. Try not to do as much as possible. I don't really think there is any case where shadowing is necessary, because the names of the variables, they should be meaningful, right? They should represent what that variable is actually storing, or what the purpose of that variable is, maybe if it's a Boolean flag. In any case, it should be a meaningful name. And if you need to shadow names, if you need to shadow a variable in inner scopes, this is pointing more towards a bad name of the variable rather than a real need for shadowing. That's it for today. If you have any suggestions, any tips, any constructive criticisms, just write them down in the comments. I'm really looking forward to hearing back from you to know how you like the channel and how I can improve. In the next video of this JavaScript introduction series, we'll talk about operators, so some basic rules, some fundamental rules that we need to understand, and a couple of examples. And as always, if you don't want to miss it, just subscribe to the channel. See you in the next videos. Bye bye.